Winston Churchill stood at the window of his underground war rooms, pipe in hand, staring at a map of the French coastline. It was November 1942, and the challenge facing the Allied forces seemed insurmountable. To defeat Hitler, they would need to land an enormous invasion force on the European continent. But every major port was heavily defended by the Germans, with concrete bunkers, artillery, and thousands of troops ready to repel any direct assault. "We must land where they don't expect us," Churchill muttered to himself. But how do we supply an invasion without a port? The traditional military doctrine was clear. Armies needed established harbors to land the massive quantities of supplies required for a sustained campaign. Capturing a port intact was typically the first objective of any amphibious invasion. But the disastrous raid on Dieppe in August had demonstrated the folly of assaulting a fortified port directly. Nearly 60% of the attacking force had been killed, wounded, or captured in just 6 hours. At a meeting of the Combined Operations Headquarters later that day, Churchill posed the question directly to the assembled officers and engineers. "If we can't capture a port, perhaps we could take one with us?" The room fell silent. Admiral Lord Louis Mountbatten, Chief of Combined Operations, exchanged glances with several officers. Finally, a Welsh civil engineer named Hugh Ioris Hughes spoke up. "It might be possible, Prime Minister. Difficult, but not impossible." Thus began one of the most audacious engineering projects of World War II, the creation of artificial harbors, codenamed Mulberry, that would allow the Allies to land thousands of men and tons of supplies on the open beaches of Normandy. In a requisitioned mansion on the outskirts of London, a team of engineers, mathematicians, and naval architects gathered under strict secrecy. The core group included Hughes, Professor J.D. Bernal, a brilliant crystallographer turned military scientist, and Bruce White, a civil engineer with extensive experience building harbors around the British Empire. Their task: to design portable harbors that could be towed across the English Channel and assembled off the Normandy coast. "The Germans will be expecting us to target a port," explained Colonel Walter Wilson, the military liaison to the project. "That's why we won't. We'll land on open beaches and bring our own port with us." The challenges were enormous. The artificial harbors would need to withstand the notoriously rough waters of the English Channel, provide shelter for vessels unloading troops and equipment, and include floating roadways to carry everything to shore. Nothing like this had ever been attempted before. During the initial design phase, fierce debates erupted among the engineers. Hughes favored concrete caissons, massive hollow blocks that could be floated across the channel and then sunk to form breakwaters. White advocated for a more flexible system of old ships and floating steel structures. Bernal, meanwhile, contributed theoretical insights about wave patterns and tidal forces that would affect any harbor design. Churchill followed the progress closely, visiting the team several times during development. "Don't argue about the difficulties," he told them during one heated debate. "The difficulties will argue for themselves." By early 1943, the design had coalesced into a comprehensive plan. Each Mulberry harbor would consist of several components: an outer breakwater of scuttled ships called gooseberries, massive concrete caissons known as phoenix units to form the main breakwater, floating piers called whales, connected to the shore by floating roadways named beetles, and an inner breakwater of floating steel structures codenamed bombardons. When assembled, each harbor would be approximately the size of Dover, capable of handling 7,000 tons of supplies per day. The plan called for 2 complete harbors: Mulberry A for the Americans at Omaha Beach and Mulberry B for the British at Gold Beach. In a nondescript government office in London, Lieutenant Commander George Fisher carefully examined the detailed plans for the concrete caissons. As one of the naval engineers assigned to the Mulberry project, Fisher understood the enormity of what they were attempting. "Each Phoenix unit weighs thousands of tons," he explained to his assistant. "A young Wren officer named Elizabeth Thornton will need to construct dozens of them in total secrecy, then somehow tow them across the channel during the invasion." Thornton studied the technical drawings with a frown. "Where will we build something this large without the Germans noticing?" "That's the next challenge," Fisher replied. "We'll need to use multiple sites around Britain's coast, constructing different components in different locations to maintain secrecy." Construction began in secret locations around the British coastline. The enormous concrete Phoenix caissons were built in hidden inlets and flooded docks. some as tall as a 5-story building and weighing up to 6,000 tons. Along the Thames and other rivers, workers manufactured the steel pontoons and floating roadways. Old ships were requisitioned to be sunk as part of the outer breakwaters. In the Clyde estuary in Scotland, shipyard worker Robert McIntyre helped oversee the construction of several Phoenix units. A veteran of commercial shipbuilding before the war, he had never seen anything quite like these massive concrete boxes. "What exactly are we building here?" he asked his foreman one rainy afternoon. "Can't say exactly," the foreman replied, glancing around to ensure no one was listening. "But rumor has it these are for something big. Invasion big, security was paramount. The workers were given only the information necessary to complete their specific tasks. The overall purpose of the components remained classified. When curious locals asked questions, they were told the structures were defensive installations for British harbors or experimental floating oil tanks." Across the English Channel, German military intelligence was aware that the Allies were planning an invasion, but they remained fixated on the major ports as the likely targets. Field Marshal Erwin Rommel, tasked with strengthening Hitler's Atlantic Wall defenses, concentrated his resources on fortifying harbors and their immediate surroundings. "The invasion will come where they can secure a port quickly," Rommel insisted. During an inspection tour of the Normandy defenses in early 1944, perhaps Cherbourg or Le Havre, the logistics of a major landing require established harbor facilities. German reconnaissance aircraft regularly photographed the British coastline, but the dispersed nature of the Mulberry construction sites prevented them from understanding what they were seeing. Individual components, divorced from the whole, appeared to be conventional maritime construction projects. In a bunker near Normandy, Luftwaffe photo analyst Kurt Weber studied recent reconnaissance images. "There's significant construction activity in several British ports and inlets," he reported to his superior. "But nothing that suggests an invasion staging area." As D-Day approached, the various Mulberry components were moved into position along Britain's southern coast. The logistics were staggering. Tugboats would need to tow the massive Phoenix caissons across the channel, a journey that would take up to 2 days depending on weather conditions. The concrete structures had been built with temporary watertight seals, allowing them to float despite their enormous weight. On June 6, 1944, the Allied invasion of Normandy began. As the first waves of troops secured footholds on the beaches, the Mulberry harbors began their journey across the channel. Over 400 towing vessels were involved in the operation, moving at a painfully slow 4 knots. Lieutenant Commander Fisher stood on the bridge of HMS Daffodil, one of the naval vessels overseeing the towing operation. "It's like watching a small city move across the sea," he remarked to his first officer, gazing back at the procession of concrete caissons, floating piers, and steel structures stretching to the horizon. On the beaches of Normandy, the initial landings had secured enough territory to begin assembling the harbors. Engineers and naval construction battalions, including the famous American Seabees, worked around the clock to position the components according to the carefully developed plans. First, the old ships were scuttled to form the outer breakwaters. Next, the massive Phoenix caissons were towed into position and sunk according to a precise pattern, creating a protective barrier against the sea. Finally, the floating piers and roadways were connected, creating a direct path from ships to shore. By June 18th, just 12 days after D-Day, both Mulberry harbors were operational. Allied supply ships began offloading directly into the artificial ports, dramatically increasing the flow of men, vehicles, and supplies to the beachhead. In his headquarters in France, General Dwight D. Eisenhower, the Supreme Allied Commander, received the news with satisfaction. "Without those harbors, we'd be fighting with one hand tied behind our back," he told his staff. "Now we can build up our forces faster than the Germans can reinforce." On the German side, confusion reigned as reconnaissance reports came in describing extensive port facilities appearing off the Normandy coast. In Berlin, Admiral Karl Dönitz, Commander-in-Chief of the German Navy, stared in disbelief at the aerial photographs showing the artificial harbors. "They've brought their own ports," he said, his voice reflecting both admiration and dismay. "We never considered that possibility." Hitler was less impressed when informed of the development. "Another British trick," he dismissed. "It will not change the outcome." These makeshift harbors cannot withstand the channel's weather. As if on cue, on June 19th, one of the worst storms in decades struck the channel. For 3 days, gale-force winds and massive waves pounded the Normandy coast. The floating bombardon breakwaters proved inadequate against the ferocity of the storm, breaking free from their moorings and, in some cases, colliding with other harbor components. By June 22nd, when the storm finally subsided, Mulberry A, the American harbor at Omaha Beach, had been largely destroyed. Mulberry B, the British harbor at Gold Beach, often called Port Winston by the troops, had suffered damage but remained operational thanks to its more sheltered location and some differences in construction. In the aftermath of the storm, Allied commanders faced a critical decision. Rather than attempt to rebuild Mulberry A, they decided to continue using the beaches at Omaha for direct landing of supplies during favorable weather while channeling more traffic through the surviving Mulberry B. German propaganda seized upon the destruction of one harbor as evidence of Allied failure. "Nature has done what our Atlantic wall could not," declared a broadcast on German radio. "The artificial harbor experiment has failed." This assessment proved drastically premature. Despite the loss of one harbor, the surviving Mulberry B operated continuously for 10 months, landing over 2.5 million men, 500,000 vehicles, and 4 million tons of supplies. Combined with the captured port of Cherbourg, which the Allies took on June 27th, but which the Germans had thoroughly sabotaged before surrendering, the artificial harbor provided the logistical backbone for the Allied advance across France. In a prisoner of war camp in England, captured German officer Colonel Heinrich Schröder was interrogated about German preparations for the invasion. "We never believed you would land where there was no port," he admitted to his British interrogator. "And we certainly never imagined you could build one from nothing. It was inconceivable to us." The interrogator, Captain James Wilson, pressed further. "But surely German intelligence observed the construction of the components in Britain." Schröder shook his head. "We saw pieces, not the whole. Without knowing the overall plan, the individual parts seemed unrelated. It was a magnificent deception." By August 1944, as Allied forces broke out from Normandy and began their advance toward Paris, the strategic importance of the Mulberry Harbor became even clearer. While the Germans had expected the Allies to be constrained by limited supply lines, the artificial port had allowed for a much more rapid buildup of forces than anticipated. "The harbor changed everything," explained General Omar Bradley to war correspondents during a press briefing. "Instead of being forced to capture a port before we could build up our forces, we brought our port with us. It gave us flexibility the Germans didn't expect." As the Allied advance continued deeper into France, the importance of the Mulberry Harbor gradually diminished as more conventional ports were captured and restored to operation. But for the critical first months after D-Day, it had provided the logistical lifeline that made the successful invasion possible. In a small English village in October 1944, Bruce White, one of the key engineers behind the Mulberry design, received a letter of commendation from Churchill himself. Reading it in his modest study, surrounded by the technical drawings and calculations that had consumed the previous 2 years of his life, White felt a profound sense of satisfaction. "We did what they said couldn't be done," he told his wife that evening. "We built a harbor like none before, moved it across the sea, and helped turn the tide of the war." In the decades following the war, the Mulberry Harbor came to be recognized as one of the greatest feats of military engineering in history. Remnants of the harbors can still be seen off the Normandy coast today, concrete sentinels rising from the sea as a testament to human ingenuity. For military planners and engineers worldwide, the lessons of Mulberry extended far beyond World War II. It demonstrated that logistical challenges previously considered insurmountable could be overcome with sufficient innovation and determination. The concept influenced later developments in offshore oil platforms, floating airports, and emergency disaster relief infrastructure. In a lecture at the Royal Society of Engineers in 1964, Sir Bruce White, knighted for his contributions to the war effort, reflected on the legacy of the project. Mulberry succeeded not just because of its engineering, but because it represented a fundamental shift in thinking. Rather than accepting conventional limitations, we asked, what if we could change the rules of the game entirely? A young engineer in the audience raised his hand. "Sir, Did you ever doubt it would work? White smiled. Every day. But as Churchill told us, don't argue about the difficulties. The difficulties will argue for themselves. Our job was to solve them, one by one. Perhaps the most fitting epitaph for the Mulberry Harbors came from Field Marshal Erwin Rommel himself, who wrote in his private papers after the war, "The Allied artificial harbors represented an entirely new dimension in warfare. We had prepared for everything except the impossible. And then the impossible happened." Today, military historians broadly agree that without the Mulberry Harbors, the Normandy invasion might still have succeeded, but it would have progressed, much more slowly, potentially extending the war by months or even years. The artificial ports that the Nazis couldn't believe existed had helped shorten the conflict and hasten the liberation of Europe. In his memoirs, published in 1953, Winston Churchill summarized the achievement with characteristic eloquence. Mulberry Harbors stand as a monument to British ingenuity, American productive capacity, and Allied determination. They remind us that in war, as in peace, the boldest solutions often emerge from the most difficult problems. We needed a port, so we built one. We took it with us, and with it, we took back Europe. In Arromanches, the small French coastal town, adjacent to where Mulberry B was installed, a museum now stands commemorating this remarkable achievement. Visitors can look out to sea and still glimpse the concrete Phoenix caissons, weathered by decades of tides but still standing, an enduring reminder of the day when the Allies brought their own ports to battle, and the Nazis couldn't believe what they were seeing. The lasting achievement of the Mulberry Harbors went far beyond their immediate military utility. In the years following the war, engineers worldwide studied the technology and principles that had made them possible. Many of the innovations developed for the artificial harbors found their way into civilian applications, from offshore oil platforms to modern container ports. Dr. Richard Hartmann, studying the harbor designs at MIT in 1953, marveled at the ingenuity of the wartime engineers. They had to solve problems that no one had ever encountered before, without the benefit of computer modeling or advanced materials. And they had to do it under wartime restrictions and absolute secrecy. One of the most remarkable aspects of the Mulberry story was that much of the credit for the initial concept belonged not to military planners, but to a civilian engineer. Hugh Ioris Hughes, the Welsh engineer who had first spoken up in Churchill's meeting, had been experimenting with portable harbor design since 1941. His early work formed the foundation for many aspects of the final Mulberry design. In a modest house near Cardiff in 1965, an elderly Hughes received a visit from a doctoral student researching the history of the Mulberry project. Now in his 80s, Hughes still kept his original design sketches in a worn portfolio. "They called me a dreamer at first," he told the young researcher, spreading the yellowed papers on his dining room table. "The naval establishment thought it was impossible. But sometimes the impossible is merely the untried." The student examined the drawings with reverence. "These look different from what was actually built." Hughes nodded. "Of course, my design was just the beginning. The final harbors incorporated ideas from dozens of brilliant minds. That was the real genius of Mulberry. Not any single person's vision, but the collaboration of hundreds of engineers and thousands of workers, each contributing their expertise. This collaborative nature extended to Anglo-American cooperation. While the initial concept had been primarily British, American engineers had made crucial contributions to the final design, and American manufacturing capacity had produced many of the components. The Seabees, the U.S. naval construction battalions, had played an essential role in assembling the harbors under enemy fire. Lieutenant Commander William Peyton of the Seabees later recalled the challenges of those first days. "We were placing massive structures in exact positions while German artillery was still active. One misplaced caisson could have compromised the entire harbor. It was like trying to build a jigsaw puzzle while someone's shooting at you." The secrecy surrounding the Mulberry Harbors extended even to many of the Allied troops landing in Normandy. Private First Class James Donovan of the U.S. 1st Infantry Division remembered his astonishment when he returned to Omaha Beach 3 days after the initial landing. "When we came in on D-Day, it was just open beach. 3 days later, I'm being evacuated with a shoulder wound. and I look out at the water and see what looks like a damn seaport appearing out of nowhere. Ships unloading, trucks driving on water, the works. I thought I was hallucinating from the morphine. The German response to the Mulberry Harbors evolved from initial disbelief to desperate attempts to destroy them. Luftwaffe raids targeted the artificial ports, but by this stage of the war, Allied air superiority made effective bombing runs difficult. U-boats attempted to attack ships approaching the harbors, but were largely kept at bay by extensive anti-submarine measures. Perhaps the most serious German effort came from their secret weapons program. On June 25, 1944, a V-1 flying bomb, one of Hitler's vaunted vengeance weapons, struck near Mulberry B, causing some damage to a floating roadway, but failing to significantly impact operations. In the aftermath, Allied anti-aircraft defenses around the harbor were strengthened, and specially designed barrage balloons were deployed to deter further V-1 attacks. The Germans never managed to land a decisive blow against the artificial ports. In his underground bunker in Berlin, Hitler raged against what he saw as another example of British trickery. "First, they fool us with inflatable tanks and fake radio traffic," he shouted to his increasingly demoralized generals, referring to Allied deception operations. Now they conjure harbors from thin air. What's next? Will they build bridges across the Rhine from cardboard? Field Marshal Gerd von Rundstedt, the German commander in the West, took a more pragmatic view. In a private conversation with his staff, he admitted, "The artificial harbors represent the kind of innovative thinking we should have anticipated. We became too fixated on conventional military doctrine. The engineering challenges of the Mulberry Harbors went far beyond mere construction. The designers had to solve complex problems related to tidal flows, seabed stability, and the physics of wave action. The Phoenix caissons, for example, needed specially designed sea-facing walls to absorb the energy of incoming waves without reflecting them in ways that would create destructive interference patterns within the harbor." Dr. Eleanor Stewart, one of the few female engineers involved in the project, specialized in hydrodynamics. Working at a time when women in engineering were exceedingly rare, she developed critical calculations regarding water flow patterns that helped determine the optimal placement of breakwater components. "The sea is never static," she explained in a 1946 lecture at Imperial College London. "A harbor isn't just a wall against water. It's a system that must work with the natural forces of tides, currents, and waves. Get the hydrodynamics wrong, and the most robust structure will fail." The Mulberry Harbors also required innovations in construction techniques. The Phoenix caissons, some weighing over 6,000 tons, were too large to be built using conventional shipyard methods. Instead, engineers developed specialized floating dry docks where the massive concrete structures could be cast and then floated out once complete. At the construction site in Southampton, project manager Robert Thompson faced a never-ending series of logistical challenges. "We were building structures larger than most buildings, using scarce wartime materials, with inexperienced labor and under strict time pressure," he noted in his project diary. And all while maintaining such secrecy that most workers didn't even know what they were building. The workforce itself represented a cross-section of British society. With so many young men serving in the military, the construction teams included older retired builders called back to service, women taking on industrial roles for the first time, and even artists and craftsmen whose peacetime skills proved unexpectedly valuable in solving unique construction problems. Elsie Crawford, a former pottery worker from Stoke-on-Trent, found herself helping to develop specialized concrete mixtures for the Phoenix caissons. "In pottery, you need to understand how materials behave under different conditions," she explained years later. Turns out that knowledge translated rather well to mixing concrete that could withstand seawater. The human ingenuity extended to improvised solutions for unforeseen problems. When certain specialized parts were delayed, engineers modified available components. When standard materials proved inadequate, they developed alternatives. The entire project embodied the wartime spirit of make, do, and mend, elevated to an engineering philosophy. Once operational, the remaining Mulberry Harbor required constant maintenance and adaptation. Special teams of divers worked around the clock to inspect underwater components and make repairs. Engineers continuously monitored tidal patterns and made adjustments to the moorings and connections between different harbor sections. Captain Richard Bellamy commanded one of these maintenance teams. The harbor was never finished, he recalled in a 1960 BBC interview. It was a living, evolving structure that we constantly modified based on experience. What worked in July might need adjustment by August as conditions changed. The logistics of the supply operation through Mulberry Bey were staggering. At its peak, the artificial harbor processed over 9,000 tons of material per day, despite its designed capacity of 7,000 tons. A complex scheduling system ensured that ships arrived at precise intervals, unloaded their cargo onto the floating piers, and departed to make room for the next vessel. Coordinating this maritime ballet fell to Commander Thomas Harrison of the Royal Navy. It was like conducting the world's largest orchestra, he later wrote. Except the musicians were Liberty ships and landing craft. The instruments were tanks and ammunition, and the concert hall was constantly trying to sink into the sea. The artificial harbor played a crucial role during critical moments of the campaign. When Allied forces became bogged down in the Norman hedgerows, the consistent flow of supplies through Mulberry Bey allowed them to maintain pressure until the breakthrough at St. Lo. During the race across France, the harbor enabled the rapid forward deployment of fuel and ammunition that kept the advance moving. General George S. Patton, whose Third Army conducted the famous breakout across France, acknowledged the harbor's importance in a message to Allied naval forces. "Without your harbors, we'd be fighting with rifles instead of tanks. The port you built from nothing is keeping my army moving." The strategic impact of the Mulberry harbors extended beyond the immediate Normandy campaign. By demonstrating that large-scale amphibious operations could be supported without capturing established ports, they influenced planning for the eventual invasion of Japan, Operation Downfall, which was rendered unnecessary by the Japanese surrender. Admiral Chester Nimitz, Commander-in-Chief of the U.S. Pacific Fleet, specifically requested detailed information about the Mulberry harbors when developing plans for landings on the Japanese home islands. "What you've accomplished in Normandy may be the key to our approach in the Pacific," he wrote to Admiral Bertram Ramsay, Allied naval commander for the Normandy invasion. As the front lines moved further from Normandy, the importance of the Mulberry harbor gradually diminished. By November 1944, with the port of Antwerp secured and operational, the artificial harbor had largely completed its mission. Yet it continued to function, handling diminishing but still significant quantities of supplies until it was finally decommissioned in late 1944. The decision to discontinue operations was pragmatic rather than technical. The harbor could have continued functioning, but the logistical demands of the war had shifted elsewhere. In a remarkable testament to the harbor's durability, parts of Mulberry Bey remained intact and in serviceable condition when engineers conducted a final inspection in early 1945. Commander William Stepson led the decommissioning process. Taking it apart was almost as complex as building it, he noted in his official report. Some components were salvaged for reuse elsewhere. Others were simply too integrated with the seabed after months of operation to be practically removed. Indeed, the legacy of the Mulberry harbors lives on physically in the waters off Arromanches. 7 decades later, visitors can still see the massive concrete caissons rising from the sea at low tide, silent sentinels, marking one of history's greatest engineering achievements. But the true legacy extends far beyond these physical remains. In the aftermath of the war, engineers who had worked on the Mulberry project found their expertise in high demand for civilian reconstruction efforts. The lessons learned about rapid deployment of prefabricated structures proved invaluable in rebuilding Europe's war-damaged infrastructure. Sir Bruce White, one of the key engineers behind the Mulberry design, went on to design port facilities throughout the British Empire and Commonwealth. "Everything I built after the war was influenced by what we learned at Arromanches," he acknowledged. Mulberry taught us to question every assumption about what was possible in maritime construction. The influence extended to emergency response capabilities. When the North Sea flood of 1953 devastated coastal communities in the Netherlands, Belgium, and the United Kingdom, engineers applied Mulberry-derived techniques to rapidly construct temporary flood defenses. The Dutch Delta Works, one of the world's largest flood protection systems, incorporated several innovations first developed for the artificial harbors. In the United States, the Army Corps of Engineers adapted Mulberry concepts for disaster response planning. Deployable temporary harbors became part of the strategic reserve for hurricane recovery operations, with simplified versions of the floating roadways ready to restore access to areas where conventional ports might be damaged. The oil industry, expanding offshore operations in the 1950s and 60s, drew heavily on Mulberry technology. The first generation of major offshore oil platforms utilized anchoring systems and sea-stabilized foundations that traced their lineage directly to the artificial harbors. Engineers who had worked on the Phoenix caissons found themselves designing similar structures for the petroleum industry. Dr. James Whitaker, who had been a junior engineer on the Mulberry project, became a leading consultant for offshore construction in the North Sea oil fields. "The principles are identical," he explained to industry executives in 1965. "You're creating a stable working platform in an inherently unstable environment." The lessons of Mulberry translate directly to what we're doing here. Even modern container shipping, which revolutionized global trade in the latter half of the 20th century, bears the influence of the Mulberry harbors. The concept of standardized, interchangeable components, a necessity for the rapidly assembled artificial ports, became a foundational principle of containerization. Malcolm McLean, often credited as the father of container shipping, acknowledged studying the Mulberry system when developing his revolutionary approach to cargo handling. "The Mulberry engineers showed what was possible when you standardize and modularize," he noted in a 1968 interview. They were solving a military problem, but the principles applied perfectly to commercial shipping. The military applications continued to evolve as well. During the 1982 Falklands War, the British Royal Navy deployed 2 logistic landing ships, LSLs, with capabilities directly descended from the Mulberry floating roadways. These vessels could create temporary harbors in areas without port facilities, allowing for the rapid unloading of supplies and equipment. Captain Michael Sterling commanded one of these ships during the Falklands conflict. "We were using more advanced materials and designs, of course," he explained. "But conceptually, we were deploying the grandchildren of Mulberry. The ability to create port facilities where none exist remains a powerful military advantage." Even the U.S. Navy's Mobile offshore base concept, developed in the 1990s, drew inspiration from the Mulberry harbors. This ambitious design envisioned massive floating platforms that could be deployed to create temporary bases anywhere in the world, independent of shore facilities, the ultimate evolution of the portable harbor concept. Naval architect Dr. Sarah Chen, who worked on the Mobile offshore base feasibility studies, explicitly referenced the Mulberry harbors in her research. "What the Allied engineers accomplished with 1940s technology remains astonishing," she wrote. "With modern materials and computer-aided design, we're still essentially building on their foundation." The educational impact of the Mulberry harbors has been equally significant. The project is studied in engineering schools worldwide as a case study in problem-solving under extreme constraints. Military academies analyze the strategic implications of artificial harbors as part of amphibious warfare curriculum. Even management programs examine the organizational aspects of how diverse teams of specialists were coordinated to achieve a seemingly impossible goal. At the United States Naval Academy, Professor Robert Harriman has taught a course on the engineering of D-Day for over 20 years. The Mulberry harbors represent the perfect intersection of military necessity and engineering innovation, he tells his students. They show how thinking beyond conventional solutions can completely transform strategic possibilities. In Britain, the Institution of Civil Engineers established the Mulberry Medal in 1968 to recognize exceptional achievements in maritime engineering. Recipients have included designers of the Thames Barrier, the Hong Kong International Airport's reclaimed island, and the Palm Jumeirah artificial island in Dubai. All projects that, in different ways, echo the audacious spirit of the original harbors. For the veterans who had operated the harbors, the bond formed during those critical months after D-Day remained unbroken. At reunions held in Oromanches, elderly engineers and sailors would gather on the beach, gazing out at the remaining concrete caissons still visible at low tide. "We built that," they would tell their grandchildren, pointing to the weathered structures rising from the sea. When they said it couldn't be done, we did it anyway. Today, the remnants of Mulberry B still stand as silent sentinels off the coast of Normandy, their concrete forms eroded by decades of tides yet remarkably intact. Tourists stand on the beaches where Allied forces once unloaded the machinery of war, trying to imagine the scale of what was accomplished here. A harbor conjured from nothing, transported across the sea and assembled under enemy fire. In the final analysis, The Mulberry Harbors represent more than just an engineering triumph or a military advantage. They embody the creative spirit that ultimately determined the outcome of World War II. The ability to imagine solutions beyond conventional thinking, to turn theoretical concepts into practical realities, and to accomplish what the enemy considered impossible. As Churchill himself noted in a speech to Parliament after the war, the Mulberry Harbors will stand as a lasting monument to the ingenuity and determination of the Allied forces. When conventional wisdom dictated that a port was essential for invasion, we simply brought our ports with us. In that decision, perhaps, lies the true story of our victory, not merely in superior resources, but in superior imagination. For the men who planned, built and operated these remarkable structures, and for the thousands whose lives were saved by the supplies that flowed through them, the Mulberry Harbors represented the perfect marriage of necessity and invention. In the face of seemingly insurmountable obstacles, they had accomplished what the Nazis couldn't believe was possible. They had built ports from nothing and changed the course of history. The end.